Intermolecular forces also help explain capillary action. So capillary action is when a liquid travels up a narrow tube. Against, the force of gravity. And so this is an example of an adhesive force. So an adhesive force is between different molecules. And you see capillary action all the time, right? That's how you get kind of a pinprick for your blood. We did an experiment with TLCs. Well, not really TLCs, but some kind of chromatography lab, but we're just going to say spotting a TLC plate. Right, where the liquid went up this little glass tube relatively easily. So one thing we need to realize is that glass itself is silicon dioxide, and it's a very polar compound. And so glass itself is polar. And remember, earlier in the semester, we said that like dissolves like. We'll change that to like dissolves / attracts like. And remember that this is the opposite of kind of opposites attract, but we're talking about different things. When we're talking about opposites attract, we're talking about positive, negative charges. When we're saying like dissolves like, we're talking about polar and non-polar, right? So they like to stick with things that are of the same polarity as them. So for example, if we have this tube, and this is a glass tube, if we put some water in it, we're going to get this kind of meniscus shape, which we've seen in lab a lot. And the reason that it kind of climbs up these sidewalls is because the water is attracted to this glass. The water is polar, the glass is polar, they can form dipole-dipole interactions with one another, and then they can stick to one another. If you tried to fill this tube up with something that's non-polar, such as mercury, you would get this kind of inverse meniscus instead, right? So in this case, the meniscus is not attracted to the glass, and so it would rather stick to itself than stick to the glass. Here's a picture of TLC, thin layer chromatography. We did paper chromatography, but it's the same thing, right? We have capillary action, which is causing our solvent to climb up here. And then you can see the molecules go on different levels based on their similarity and thus attraction to the paper. Another good example of this kind of stuff is like the Rain-X that you can buy for your windshields. And, you spray it on your windshield, and then when it rains, it's a lot easier to see because the water doesn't stick onto the windshield as much. Or like when you wax something. Either way, you're putting a non-polar coating on it. And so if you think about water normally, right, it does form kind of this little bulb, but there's still attraction to the glass. It still likes to touch the glass. And so it'll stay relatively, kind of spread out. If you put some kind of non-polar coating, the water will not want to stick to the non-polar coating, and so it'll form much more of a bead as it tries to mostly just stick to itself, and then it can kind of, go away much easier. So pretty cool. Intermolecular forces are a big deal, and they help explain a lot of what goes on in your daily life.